Hello, my name is Jose Maria Sanchez Carvajal. Firstly, I would like to thank the organizer for taking this communication and the opportunity to share with you our recent work entitled Evaluation of Droplet Digital PCR Targeting IS6110 to Detect Mycobacterium Tuberculosis Complex DNA in Microbiological Culture and Fresh Tissue Samples. Bovine tuberculosis is a chronic infectious disease caused mainly by Mycobacterium bovis and Mycobacterium caprine, but also other members of the Mycobacterium tuberculosis complex. This complex affects various species of mammals, including human. Bovine tuberculosis is considered a neglected zoonotic disease of global importance causing a detrimental impact on public health, particularly in developing countries where tuberculosis is likely to remain a major health problem because the control and surveillance programs for this disease are inadequate or are not carried out. In the European Union, bovine tuberculosis mainly affects livestock, with cattle playing a key role as the primary host. It's important to mention that there are territories struggling to eradicate bovine tuberculosis at a high level in several European countries, where domestic and wild animals often share pasture, and currently debate around the efficacy of this measure are an ongoing matter of concern. Bovine tuberculosis is subjected to national eradication program based on skin testing of all registered cattle herd, slaughter policy, and abattoir surveillance. Although a substantial sum of public funding is addressed to ensure efficient surveillance system and control program, the detection and confirmation of bovine tuberculosis infection in cattle herd should be more reliable and swifter. In this context, another point to highlight is that the current diagnostic procedure for bovine tuberculosis is time-consuming and laborious. Therefore, it would be critical to set up rapid and accurate PCR-based techniques to confirm bovine tuberculosis infection. Droplet digital PCR is a promising diagnostic tool in infectious diseases that could overcome the problem in accuracy of real-time PCR, because it's more sensitive and specific for the identification of low abundance DNA. Digital PCR is currently used to detect Mycobacterium tuberculosis in human samples. Nevertheless, to our knowledge, there are no studies evaluating the detection of Mycobacterium tuberculosis complex in animal samples by digital PCR. The main goal of the present study was to evaluate the capacity of digital PCR to detect Mycobacterium tuberculosis DNA in culture and fresh tissue samples, targeting the IS6110 sequence. A total of 49 fresh lymph node tissue samples were collected from cattle carcasses during their routine official veterinary postmortem examination. Pair samples from individually homogenized fresh tissue were subjected to microbiological culture and DNA extraction to perform real-time PCR and digital PCR. For digital PCR, when the samples had 2 or more droplets were considered positive, while samples with only one event were considered as questionable or weak positive. Firstly, we're going to evaluate the result for culture. In case of real-time PCR, we were able to detect 16 positive samples and 33 negative ones. By contrast, with digital PCR, 19 samples were disclosed as positive and 30 as negative ones. Okay, have a look in the box plot. We can see positive droplet in blue line and negative droplet in gray. The software determined the threshold to discriminate between negative event and positive one. These samples were disclosed as positive, and the samples with only one event were considered questionable or with positive. In the bar chart, choose the number of positive droplets in light blue and -1 in dark blue. It's important to get optimal results that the minimum number of accepted droplets per well was at least 10,000. Okay, well, in the case of 3 samples, real-time positive but negative for digital PCR, these samples were considered as questionable or weak positive because only one event was found. In the case of 4 or 6 samples, positive for digital PCR but negative for real-time PCR, we found macroscopic or microscopic light lesion. When the PCR was run directly in fresh tissue samples, 20 positive samples and 29 negative ones were found with real-time PCR. On the other hand, with digital PCR, 28 samples were disclosed as positive and 21 as negative one. Both samples, positive for real-time PCR but negative for digital PCR, were considered as weak positive. In the case of 5 of 10 samples positive for digital PCR but negative for real-time PCR, we found microscopic tuberculosis light lesion. Finally, we could conclude that this result point to digital PCR could be used to detect low levels of Mycobacterium tuberculosis DNA in microbiological culture and fresh tissue samples, with a higher analytical sensitivity than real-time PCR. Thus, digital PCR targeting IS 6110 could be a potential method to confirm bovine tuberculosis in animals with either tuberculosis like lesion or non-visible lesion. Last but not least, we should say that this study was part of a large project carried out in order to find new measurement techniques to control bovine tuberculosis and was supported by operational group of the European Innovation Partnership for Agriculture, Productivity and Sustainability. Thank you.